In this part of the question, we are going to try find the series expansion for this expression here up to and including the x squared term. So for the numerator, we can already do an approximation for this into a polynomial form, which is 1 minus 2x squared over 2 factorial. And the same goes for the denominator. Since x to the power of 3 is going to be negligible, we are expanding this up to the x squared term. So tangent will be approximated to tangent of that small angle. Tangent x will be approximated to x. So this is going to be 1 plus x, then square. And as for what we have here, it is going to be a 1 minus 2x square, and I'll just let it be. But for the denominator, we are going to shift it up to make it into a 1 plus x to the power of minus 2, so that we can apply further expansion for this into a polynomial form. Then we can do an ultimate expansion to get the entire expression to become a polynomial. So this will be 1 minus 2x squared still. As for this that is here, it is going to be 1 plus minus 2, then x, then plus minus 2 minus 3 over 2 factorial x squared. And the next term will be x to the power of 3. We're going to be ignoring that. So I'm going to just put a plus dot here. This is going to be 1 minus 2x squared. And here we will have a 1 minus 2x plus 3x squared, and so on. Doing one final expansion, 1 multiplied by this is going to be 1. Multiplying by this is minus 2x, and multiplying by this is plus 3x squared. And this multiplied by this is minus 2x squared. This multiplied by this gives us a x to the power of 3 that is going to be negligible. So the rest, I'm going to just let it be within this plus dot. So my final answer here is going to be 1 minus 2x plus x squared, and so on. Okay, this is for part A. Let's take a look at part B together. In B part 1, we are supposed to find the numerical value of f prime x when x is equal to 0.01. So we're going to be trying to press this into our calculator. And if I were to make use of my calculator, pressing it in, we will have this. So based on this, my answer is going to be 0.49007. And this is to 5 decimal places. This is for part 1. Let's take a look at part 2. And in part 2 of this question, we are going to use the standard series from our list of formulae to try to expand fx as far as the term x to the power of 3. So let's take a look at fx that we have here. This, I think it is fine. We can definitely make use of our list of formulae to try to find it. As for this, we should do a bit of tweak. Okay, we want to see this as x plus 1 plus x to the power of half. So we can rewrite this into half ln of 1 plus x. Half, I'm going to bring it forward. Then we will have a 1 minus x to the power of half. And we will have a ln 1 plus x. And now we can make use of what we have in our formula sheet, which is going to be this portion that is here. So for this, we are going to make use of this particular result. And making use of that result, it is going to be 1 plus half, then minus x, then plus half minus half divided by 2 factorial minus x squared. And the question asks us to expand all the way until the x to the power 3 term. So let me write down one more term. It will be half minus 3 over 2 divided by 3 factorial minus x to the power of 3. And this is going to be for the expansion of this. As for this, we will just copy directly from what we have in our formula sheet, which is going to be this one that is here. So with that, here is going to be x minus x squared over 2, then x to the power of 3 over 3, and so on. Simplifying this, we will have a half here. This is going to be equal to 1 minus half x minus 1 over 8 x to the power of 2, and minus 1 over 16, x to the power 3, and so on. As for this, it is going to be x minus half x squared plus 1 over 3 x to the power of 3. Let's do one more expansion, this time keeping only terms that are x to the power 3 and below. So it is going to be equal to, if I were to do that, it will be half, then x minus 1/4 x to the power of 2 plus 1 over 6 x to the power of 3 minus 1 over 4 x to the power of 2 plus 1 over 8 x to the power of 3 minus 1 over 16 x to the power of 3, and for the rest, they're going to be higher than x to the power of 3. So with this, one more simplification give us our final answer here as 1 over 2x minus 1 over 2x squared plus 11 over 48 x to the power of 3, and so on. This question also asks us to find out the range of values of x for which this expansion is valid. And to do this, to get this expansion, we expanded this and we expanded this over here. And if I were to look at what we have in our formula sheet, in order for us to expand this, we were using this, and this comes with a range of values such that the expansion is valid. So applying this to this portion here, the range of values that this expansion will be valid will be, for this, it will be modulus of minus x to be less than 1. We are replacing this x here by minus x. As for this, we are using this directly, so we're going to use this condition. So it will be this, and the other condition will be x is going to be strictly bigger than minus 1 and less than or equal to 1. And combining these two together, my final answer is going to be x to be strictly bigger than minus 1 and strictly less than 1. Okay, this is going to be for part 2 of the question. Part 3. Part 3 denoting the answer in B part 2 as gx. So we are going to be looking at this portion here, B part 2. We're going to be looking at this portion here as gx. So with this portion as gx, the question requires us to hence find g prime x when x is equal to 0.01. Let me write it down here. So part 3. Gx is going to be equal to 1 over 2x minus 1 over 2x squared plus 11 over 48 x to the power of 3. So let me first find g prime x. It is just a simple differentiation of a polynomial. This will be this minus away x. Then here it will be plus 11 over 16 x to the power of 2. And our objective is to try to find g prime 0.01. Okay, we are trying to find g prime x when x is equal to 0.01. So g prime 0.01, which is going to be half minus 0.01 plus 11 over 16, 0.01 square. If I were to press this into the calculator, this is going to be getting me a 0.49006875, which is approximately 0.49007 to 5 decimal places. And with this as my answer for gx, according to what we are asked in the last part of the question, part 4 of the question, part 4 of the question requires us to compare our answers in B part 1, which is this, and now to also our answers in B part 3, which is this. Okay, we are comparing this answer to this answer. They are exactly the same to 5 decimal places. But before we can conclude that this is going to be a valid estimation, this answer is valid, we still need to check one more thing, which is the range of values of x such that the expansion that we are looking at here is valid. The x that we are using here is 0.01, and the range of values of x such that the expansion is valid requires x to be between minus 1 and 1. So 0.01 is within the range of values such that the expansion is valid, and we are getting an answer that is actually the same as the answer that we got from B part 1 to 5 decimal places. That is why we can conclude and comment that our answer here is valid.